If you remember one thing only, cosine on the x-axis, sine on the y-axis, then your life will be much easier. But instead of starting with this, let me show you some real-life animations where you can actually see sine and cosine. Remember, cosine horizontally, x-axis, sine vertically, y-axis. Let us begin.
So, as we said, every horizontal movement is cosine, okay? So here are some animations for you to remember. Horizontal movement, which is left or right, is cosine. Two boats, left and right, cosine. We have a car, they go left and right, cosine. Now, a sine is vertical movement. So whatever goes up and down, a ball up and down, it represents sine on the y-axis. A trampoline up and down, it's sine as well. Heartbeats up and down, it's a sine function.
Alright, so this is where basically everything begins. Everything we say in trigonometry has to do only with right angle triangles. Alright? So no acute and no obtuse triangles. It's only right angle triangles. Alright. Now, let's say we have a right angle triangle. A right angle triangle is a triangle that has one angle of 90 degrees. I hope that one is fine. Let us assume that this angle here is theta. I will use Greek theta to mark this angle. Now, it's important that we know that side that is right across to that angle is called opposite side. So a side that is exactly opposite to the angle is called opposite side, right? Side that our angle is lying on is called adjacent. So the one on the bottom is called adjacent side, the one that our angle lies on, while the one that is on the opposite direction is called opposite side. Finally, the longest side in every right angle triangle, the one that is right across the right angle, is called hypotenuse. Alright, so here are the basics: opposite side, adjacent side, and hypotenuse. Now, in order to find the sine value, cosine, or tangent value, it's very important that we know this. So, ka, toa. Basically, SOHCAHTOA solves everything for us. Let's start with SOHCAHTOA. So, S stands for sine, right? Now, O stands for opposite, H stands for hypotenuse. And then we have again, C stands for cosine. A is adjacent, H is hypotenuse. And then finally, T stands for tangent. O stands for opposite, and A stands for adjacent, right? Okay, then what does that tell you? If we have so, that one is for sine. So to find sine, we basically say, let's say sine of angle theta, we only have to divide what? Opposite by hypotenuse. Opposite over hypotenuse. Okay, let's do it again. To find cosine of angle theta, we only have to divide what? Adjacent over hypotenuse. And finally, to find the cosine, to find the tangent, we only have to divide what? Opposite over adjacent. Now, if we know this, then we can basically find sine and cosine of any angle that is given. let's have a practice, okay? We have a right angle triangle, and let us assume that this is the angle that we are looking at. I will say that this side here is 3, this side is 4, and this side is 5. Now, to find the sine of my angle, what did we say? So, ka, to, right? So, sine of our angle is opposite over hypotenuse, which means opposite over hypotenuse, 3 over 5. Done. Cosine will be adjacent over hypotenuse, which means adjacent over hypotenuse. So 4 over 5. And finally, tangent of our angle will be opposite over adjacent. Opposite over adjacent, which means 3 over 4. Now, if that is clear, we can go back to the unit circle and explain how to find sine and cosine of all other angles. But again, before we jump into the unit circle, let's go back to a right angle triangle that has 30 degrees and 60 degrees. Okay? Let us do that first. Alright, let's have a triangle that has angles of 30 degrees, 60 degrees, and 90 degrees. Now, it's very important what the sides are. The side that is opposite to 30 degrees is always 1, while the longest side is 2. Now, what is the shortest one? You can use Pythagoras to solve it. Okay, let's say it's x. You know that to find x squared, you add 1 squared, that is equal to hypotenuse squared. Now let's solve it quickly. X squared is equal to this minus this. 4 minus 1 is equal to 3. Basically, x is equal to square root of 3. So, we have it. This side here, it's 1. This side here is radical 3, and this side here is 2. Now, so that's what we said, right? So, ka, to. Let us find sine of 30 degrees. We say sine is opposite over hypotenuse, right? Opposite to 30 degrees is 1. Hypotenuse is the longest one, so it's 1/2. And then we have cosine of 30 degrees. We do the same thing again, but this time adjacent over hypotenuse. Okay, adjacent to 30 degrees is radical 3 over hypotenuse, which is 2. That's it. Now let's do tangent. Tangent of 30 degrees is equal to opposite over adjacent. Opposite over adjacent, which means 1 over radical 3. Perfect. Then we have sine of 60 degrees. What is sine of 60 degrees equal to? Our angle of 60 degrees is the one on top, right? We say sine is basically opposite over hypotenuse. Opposite to 60 degrees is radical 3. So radical 3 over hypotenuse is 2. Then we have cosine of 60 degrees. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse, which means 1 over 2. And then if we want to find the tangent of 60 degrees, we can do it as well. It will be opposite over adjacent. Opposite to 60 degrees is radical 3. So radical 3 over adjacent to 60 degrees is 1, which means radical 3 over 1, which is basically radical 3 only. Now, remember these values here because we will use them later for the unit circle. If we do the steps again for 45 degrees, let's see what we get. Okay, let's say we have a triangle that has 45 degrees here, 90 degrees here. Oh, but what does that mean? Then it means that this angle is also 45 degrees, right? Because 45, 45 and 90 is equal to 180 degrees. Okay, if two angles are equal, then it means that those two sides are equal as well. That's the property that we use. This one is equal to 1, this one is 1. Now, if we apply Pythagoras, we get that this is radical 2. Okay, let's find sine of 45 degrees. Let's find cosine of 45 degrees. And finally, we can find the tangent of 45 degrees. All right, sine of 45 degrees, remember, so, which is opposite over hypotenuse. Opposite over hypotenuse, which is 1 over radical 2. Now, in some books, you will see that they rationalize this because a radical in denominator has to be rationalized, which means we multiply by radical 2 and we multiply by radical 2. So 1 by radical 2 is radical 2, radical 2 by radical 2 is 2. And this is the answer, okay? So we only rationalize the denominator. Okay, cosine of 45. So k, which is adjacent over hypotenuse. Oh, but don't we get the same thing again? 1 over radical 2, which is basically equal to radical 2 over 2. So sine and cosine have equal value for 45 degrees. Finally, tangent is equal to opposite over adjacent, which is basically equal to 1 over 1 equals 1. That's it. So far we have learned how to find sine, cosine, and tangent of 30 degrees, of 45 degrees, and of 60 degrees. And those are the most important three. Now, to find the rest, we use the unit circle. And the most important part of the lesson starts now. All right. So, as we said, this is the most important part of the lesson today, okay? Let's assume we have a unit circle, okay? This what we see is what we call a unit circle. A unit circle is a circle that has a radius of 1. Now, if on this unit circle we find any point, let us zoom in and focus on this point here, for example. Let's mark it with P as point. Now we know that this point P has two coordinates, x and y. Now, if we have the first coordinate, x, is the length on the x-axis, right? So x coordinate is the value on the x-axis, while y coordinate is the value on the y-axis. All right, that is clear. Now, if we have a right angle triangle that goes from this point to the origin, and we assume that here is the unknown angle, the one that we are looking at. Now let's mark it with theta. No problem. We have a right angle over here. What is the length of the center of the circle to point P? If I zoom it out, what is the length of that? Remember, we said that this is a unit circle. So if it's a unit circle, then the value is 1. So the length that is from the center to point P is equal to 1 because it represents the radius of that circle. All right. Now, let us focus on this angle again. If I ask you, what is the sine of that angle? Remember what we said. So, ka, to, right? Now, if we say sine is opposite over hypotenuse, okay, what is opposite to our angle? Here we know it's y, right? So opposite over hypotenuse. Hypotenuse is the longest one, which is 1. Aha, y over 1 is basically y. Alright, so guys, this tells us that sine is basically the y coordinate. So this value here is sine of angle. Okay, so sine is, or sine has to be found on the y-axis. This is where we find the sine value on the y-axis, either positive y or negative y. It depends, right? Okay, now let us continue. What is the cosine of our angle? Cosine, according to this formula, is adjacent over hypotenuse. Adjacent to my angle is x over hypotenuse is 1. X over 1, which is equal to x. Okay, so we have it again. It says that cosine of angle is equal to x, which means that x always stands for cosine. But what is x? X is the horizontal one, right? The one on the bottom. So this value here is basically our cosine. And that's the most important part of the lesson. So, sine value is on the y-axis. So, sine either goes up or down, while cosine value is on the x-axis. So, it goes to the right or to the left. And then if we have another example, so here it is, point P. This value here on the bottom we said is our cosine value, while this value on top is the value on the y-axis, and that is our sine value. Okay, if we have another unit circle, so this one, for example, let's say this time our point P is over here. Okay, we know that coordinates are x and y, and now we know the first coordinate represents the cosine value. Okay, the cosine value is this value over here, right? The value on the x-axis, which means this length over here. So our cosine will be negative something, right? While y-axis represents the sine value. The sine value can be read from the y-axis. So this one here stands for sine, while this one stands for cosine. All right. Now let us see the signs of the functions in different quadrants. Let's assume our point P is in the first quadrant, right? We know that the first value stands for cosine, x, and the second value stands for sine, y. What are they? Our x value over here, so our sine will be positive, right? While our sine value, the one on the y-axis, this one is positive as well. Okay, let us move on to the second quadrant. If we have any point, for example, this point over here, the cosine value and the sine value. The cosine value will be something negative, right? While the sine value, the one on the y-axis, is still positive. Perfect. Let us move on to the third quadrant. Okay? Any point. This point over here. First of all, cosine and sine. Cosine is on x-axis, right? So on x-axis, we still have a certain negative value, while sine is on the y-axis. Oh, but this one is a negative number as well. Finally, we go to the fourth quadrant. Let's say we have a point that belongs over here. Again, this point has cosine and sine, our x and y coordinate. X coordinate, cosine is, it is something positive, right? While y coordinate is on the y-axis and our sine is negative. Okay, with this we have learned how sine and cosine behave in 4 different quadrants. But the most important thing, x and y, the first coordinate, the one that tells us if we go to the right or to the left, stands for cosine. The y coordinate, the one that tells us how much we go up or down, is the one that stands for sine value. Alright, the final part of the lesson. We learn now how to find sine and cosine of all basic angles. Alright, let us now start with 0 degrees first. Alright, 0 degrees. 0 degrees, it means we are here. So it's basically this value here. Okay, when we are at 0 degrees, we remember this point here. We remember that cosine is the value on the x-axis, while sine is the value on the y-axis. Now, to reach this point here of 0 degrees, our x value is 1, right? While our y value, we did not go up or down. So basically our y value is 0. Oh, so this tells us that cosine of 0 degrees is 1, while sine of 0 degrees is equal to 0. Alright? Now, what happens if we go all the way up until we reach 90 degrees? Okay? So we are at this point here because we want 90 degrees. So, what is the cosine of 90 degrees and what is the sine of 90 degrees? So what do we have? Cosine at this point here. This point here means we are here at the region. Did we move to the right or to the left side? Nope, we did not. That means that cosine is 0. Right? Well, what happens with the sine value? Sine value, remember, it's on the y-axis. To reach 90 degrees, we go all the way up. So our sine value here is 1 because our y value is 1. Alright, what's the next one? Now we go to cosine of 180 degrees and sine of 180 degrees. So, cosine of 180 degrees. 180 degrees is all the way here, right? Cosine, remember, is on the x-axis. So, how much did we move on the x-axis to reach 180 degrees? Oh, this value here, our x-axis is -1. So, Cosine of 180 is negative 1. Perfect. Sine of 180, did we go up or down at this value here? Nope, we did not. We stayed in the region, which means the sine of 180 degrees is 0. Perfect. Let us move on to the next one. Then we have cosine of 270 and sine of 270. 270 degrees is, okay, let us remove everything else. 270 degrees, we start from here until we reach this point here. Yes, because this is 270 degrees. Okay, what happens with the cosine value first? Did we move to the right or to the left? Nope, we are exactly in the region, so our cosine is 0. But our sine tells us whether we move up or down, right? We did move down on the y-axis to the point -1. So it is -1. And the final one is 360 degrees. But what happens with 360 degrees? Isn't that the same as 0? So 360 degrees is basically here. So we are back to 0. What's the value of cosine? Remember, cosine is on the x-axis. On the x-axis, the value of cosine is 1. Alright, what happens with the sine of 360 degrees? Sine is our y value. Did we move up or down? Nope. So the sine value is 0. Alright, and now we finally learn how to find sine and cosine of any other angle. So, we did 0 degrees, we did 90 degrees, we did 180 degrees, we did 270, and we did 360 degrees. Done. Now, we have 30 degrees. Let's go over multiples of 30. So we have 30 degrees, we have 60 degrees, 90, it's done already. Then we have 120 degrees, 150 degrees. And that's it with first two quadrants. Okay, let's start with 30 degrees. The one that we see over here, 30 degrees, right? The only thing that we have to remember is the lengths that we know. If this is the angle of 30 degrees, opposite to 30 degrees is 1, hypotenuse is 2, the one on the bottom is radical 3. That was explained already. And then we start. Sine of 30 degrees, we know already, right? So katoa, opposite over hypotenuse, it's 1/2. Cosine of 30 degrees is adjacent over hypotenuse, which is radical 3 over 2. Done. Let us move on to the next angle. Look what happens when we move to 60 degrees. So this angle here is 60 degrees now. And then again, opposite to 60 degrees is what? What did we just say? So in our triangle this time, opposite to 60 degrees is radical 3, hypotenuse is 2, and the one on the bottom is 1. And then again, we go quickly. So sine of 60 degrees is, what do we say? Opposite over hypotenuse, radical 3 over 2, right? Cosine of 60 degrees is adjacent over hypotenuse, which is 1 over 2. 60 degrees, done. What's the next angle? 120 degrees. Let us show it here. So 120, 90 degrees, done already, right? We open it more until we reach 120 degrees. Okay, when it's 120 degrees, what do you notice? Let's go back to 60 degrees. So pay attention here. We are at 120 degrees. This is my cosine, and this is our sine, right? If I go back to 60 degrees, 60 degrees is here. This is cosine, and this is our sine. So what do we notice then? Our sine at 60 is the same as sine of 120. That's the same positive value, right? The only thing that changes is cosine. Cosine was positive for 60, and now cosine is negative for 120. All right, so what did we say then? Sine of 60 remains the same as sine of 120, which is basically radical 3 over 2, right? Now cosine of 60 is positive 1 half, while cosine of 120 is a negative 1 half, and that's it. So negative 1 half. Here they represent it using decimal numbers, so they say negative 0.5. Perfect. Now we have 30 degrees. Where was 30 degrees? 30 degrees was here, right? Now, what do we notice here? 30 degrees will be the same as, what if I go to the other side? All the way here, and then I have 150 degrees, right? So 150 degrees is here, while 30 degrees is the same thing on the other side. So basically, what do we notice? Our sine here and here remains the same, right? While cosine is negative. So, in order to represent that, let me show it on a unit circle. Here it is. 30 degrees is over here, right? This one is 30 degrees. Now, what do I know? This is our sine, and this is our cosine, right? Now, if we go to 150 degrees, 150 on the other side, and we have the same thing. Our sine is here, and our cosine is here. So basically, sine of 30 degrees is the same as sine of 150 degrees, and it is 1 half. While cosine of 150 degrees would be only negative cosine of 30 degrees, which is negative radical 3 over 2. Okay, so now we know 30, 60, 90, 120, 150, and we know 180. Let us show it here. If it's easier, we can show it on the unit circle that we see here. So 30 degrees, remember first value is cosine, radical 3 over 2, the other value is 1 half. Okay, if we go to 150 degrees, then we basically have the same thing where our cosine is negative. So negative radical 3 over 2 and positive 1 half. Okay, now let's go back to 60 degrees. It's the one that has 1 half for cosine, radical 3 over 2 for sine. And then the one that has same value but opposite cosine is the one on the left side, where cosine is negative and then the rest remains positive. Okay, but what if we go further, more than 180 degrees? What happens then? What if I go to 210 degrees? Oh, but that one is the same as which one? As 30 degrees. So here our cosine is positive, sine is positive, while here both cosine and sine are negative. Is there another one that has the same value? Yes, of course. If we go to 330 degrees, then you can see that these two have same values. They both have positive cosine, right? While for this angle here, for 30 degrees, sine is positive, right? While for this angle here, the one of 330 degrees, sine is negative, but the rest remains the same. Perfect. Then let's do it again with 60 degrees. We know that 60 degrees is the same as 120 degrees, right? Just the opposite side. Oh, but what's the next one? What is this angle over here? If I add 60 degrees to 180 degrees, then we get what? 240 degrees. Oh, it's this angle here, right? So do we agree that it's the same value? So here cosine was positive, while here our cosine is negative, right? Here our sine was positive, while here our sine is negative. And there is one more. If we add another 60 degrees, so we have 300. Yep, this angle here easy to be found, right? So cosine remains positive for both 60 and 300 degrees, while the only difference is for 60 my sine is positive, right? Radical 3 over 2, while for 90 my sine is negative. Negative radical 3 over 2. Perfect. The last thing that we will revise today is multiples of 45 degrees. Do we remember when we have 45 degrees, it's radical 2 over 2 for cosine and radical 2 over 2 for sine. Now, if I go from 0 and add 45 degrees, we get 45, right? But what if we go from 180 and we go backwards for 45? Or if you find reflection of this in the y-axis, aren't they going to have the same value? Yes, of course. So if we find now angle of 135 degrees, then we get the same thing. So for 45 degrees, sine was positive, radical 2 over 2, while for 135 degrees, oh, sine is also positive, radical 2 over 2. Cosine was positive, radical 2 over 2, but for 135 degrees, cosine is negative. And that's the only difference, right? So if you know 60, then you know 135. The only difference is cosine was positive, now it's negative. Okay, then what's the next one? What if we add 45 to 180? The next angle is 225 degrees. Yep, it's the same thing here. For 45 degrees, sine is positive, radical 2 over 2. But for 225 degrees, sine is same value, but negative, radical 2 over 2. Perfect. Cosine was positive, right? And now our cosine is negative. So negative radical 2 over 2. Let's add another 45 degrees. So if we have 315 degrees, it's the last one. Yep, they have the same value for cosine. It was positive, it remains positive, radical 2 over 2, right? And our sine was positive for 45 degrees. Now it's negative for 225 or for 315 degrees. And with that, we are done. So now you know how to find sine and cosine of 0 degrees. What did we say? 1 for cosine, 0 for sine. We didn't go up or down. Then we know for 90 degrees, it's opposite this time. Cosine is 0. We did not move right or left. Sine is 1. Then we learned 180 degrees, right? This time cosine is negative 1, while sine, we didn't go up or down, remains 0. Then we learned 270 degrees. Cosine cosine remains 0, right? We didn't move right or left, but sine is negative 1 because we moved 1 unit down. And then we learned if you know 30 degrees, then you know 120 degrees. And then you know 150 degrees, right? And you know 210 degrees, right? And then you know 330 degrees, right? And if you know 60, then you know 120, then you know 240, right? And then we know 300 degrees. With that, we are covered for the all values of of the unit circle. And one last thing for today, to find the tangent of any of these angles. Just remember this. Tangent is equal to sine over cosine. So if you need to find, let's say, tangent of 45 degrees, then you can basically divide. What was sine of 45 degrees? Sine of 45 radical 2 over 2. Over, what's cosine of that? Cosine of 45 degrees, radical 2 over 2. Oh, when I divide radical 2 over 2 by radical 2 over 2, then we get 1. So tangent of 45 degrees is equal to 1. Using this formula, you can find the tangent of any angle because you know sine and cosine of all of them. Any questions you have, make sure that you write the comments. I'll try my best to help you.